the semester, particularly when we're talking about the autonomic nervous system and the fight and flight response, and things of that nature. And you guys know that when you have a lot of stress in your life, what that means is that number one, your autonomic nervous system, which has these two divisions, sympathetic and parasympathetic, but you're going to have a lot of what? Sympathetic activity, and you're going to have less what? Parasympathetic. Okay? And of course, you guys know that your heart rate goes up, ventilation rate goes up, all that stuff goes up, and what happens is that a critical gland in dealing with that type of stress is the adrenal gland. Okay? And the adrenal gland, like the pituitary gland, is two glands in one. And they have two different embryological origins, but yet they're combined into this one gland that sometimes we do loosely call the adrenal gland. But it is divided up into adrenal cortex and an adrenal medulla. They're separate. Okay? Excuse me. Now, what you can see here is this, is that when you have a fight and flight response, or you're just under a lot of stress, whatever, there's going to be a lot of sympathetic activity. It's not going to be much parasympathetic. Now, you have to go back to the autonomic nervous system lecture, but when you have a lot of sympathetic activity, the hormone that is secreted on the organs is what? There were two. There was epinephrine and there was acetylcholine. It is what, everybody? It was epinephrine. Okay? And so what I see here is that when you have a fight and flight response, what is going to happen is that there are nerves that go from your hypothalamus to the adrenal medulla. And matter of fact, we covered this a little bit with the heart, I believe. Okay? And so what happens is the adrenal medulla is now going to secrete what? Epinephrine and norepinephrine. And so the result is your heart's going to beat faster, ventilation rate is going to go at an enhanced rate, and non-critical organ systems such as digestive, reproductive, or whatever is going to be depressed. Okay? And so you're going to maintain that fight and flight response, which is also interesting that if you have a fight and flight response, then all of a sudden you realize, gee, there's nothing to be frightened about. You don't go back to normalcy right away. It takes some time to clear these hormones. Okay? Now, the other issue here is this. If I'm going to have enhanced heart rate, ventilation rate, blood pressure, I'm going to be ready to run or fight or flight. Guys, that takes energy. That takes energy. That takes a lot of energy. And you need energy now. Well, what if you are far away from Market Basket and you haven't eaten for 12 hours? You need energy. So you know what's going to happen? We're going to make energy real fast. And so what's going to happen is this, is that at the same time that this is going on, I'm going to have this cascade of these tropic hormones where my hypothalamus is going to start secreting corticotropic. There's that word tropin again. Okay, so I'm going to influence another endocrine gland. Okay, corticotropin, and it'll be the adrenal cortex, corticotropin releasing hormone. And that's now going to enter into the fenestrations, go through my hypothalamic hypophyseal portal system, come to my anterior pituitary gland, and now it's going to start secreting adrenal cortex, corticotropic hormone. And so now that comes in contact with my adrenal cortex, and now my adrenal cortex begins to secrete these steroid hormones. These what? Steroid hormones called glucocorticoids. Okay? And the glucocorticoids now are going to come in contact with your liver. We covered this with the digestive system. A lot of you guys did well. You remember that matching in all L's? Remember that one? Did you like that?
No, you can't remember that.
Say what?
You can't remember it.
What? You didn't study hard.
I did. It was
Did you? It's all in the video. Just did the liver. The liver does everything. Right? All right, well, at any rate, what happens is these glucocorticoids are going to come in contact with the liver and even other organs as well. And they're going to cause this process called gluconeogenesis. Called what? What gluconeogenesis is, it's a very rapid process where I start making glucose from non-carbohydrate sources. Okay? And so what will happen, of course, is I can start doing beta oxidation. And I can start getting acetyl groups. And you guys remember glycolysis will go from glucose to pyruvate, right? You know, and then the acetyl group. Well, that can go in reverse. Okay? And so what will happen is I can start making glucose. So by breaking down fat, I can start making glucose. The metabolic pathways do a little bit of a deviation from that. There's some other enzymes. But I can start making glucose. So now pouring out of your system is going to be a whole lot of glucose. And what's sort of weird, you may not have eaten, you may have this fight and flight response, but you've lost your appetite. And you have found energy that you didn't know you had. Do you guys see? And so we can start making glucose from non-carbohydrate sources. You guys remember that when we did the liver function and the digest, I think I had you guys do that on your own. But you guys remember when you had the Krebs cycle, at all those different points, I can start making non-essential amino acids, right? Well, likewise, I can do deamination. I can take those amino acids, I can feed them back in, and I can take those products, and they can go go the other direction and start making glucose. And so what happens is the epinephrine and norepinephrine will help to maintain and sustain the fight and flight response through time. And the glucocorticoids are going to give me the energy in order to do that. Do you guys see? Okay? And it's a stopgap process for doing this. You don't want to maintain these glucocorticoids for the long term. You know, it's to give me some energy for this immediate problem that I'm having. But but some people who are under chronic stress all the time, you know, it could be psychological or whatever, and it happens, and their body keeps producing what, everybody? Glucocorticoids, and eventually what happens is that can have an adverse effect because our body's not designed to sustain that type of fight and flight response all the time. You guys see?
Just wondering if that also affects the pentose phosphate pathway.
The what?
The pentose phosphate pathway.
I'm sure it does, but I would have to review that. What course did you study that in?
Okay.
Okay. Right here's some of the other effects of the epinephrine, but it maintains vasoconstriction, so my blood pressure stays up. Cardiac output increases. Blood is redirected. Remember, fight and flight response. If I'm going to have a fight and flight response, if I'm going to fight, I need my muscles. If I'm going to run, I need my muscles, okay? And if I am going to fight or run, I really need to get away from some source of that stress. I really need to be focused. And so blood is redirected not only to my musculature, but also to my brain so that I can, think clearly. And usually when you have that fight and flight response, you're pretty lucid. That's why I always say when you guys are studying, a little bit of stress is like salt on food. It just makes it a little bit better, right? Not too much, but just a little bit to just keep things going.
Until your eye twitches, right?
No, then it's over. It's too much at that point.
I've had a few of those weeks.
Alrighty, and of course you're ventilating a lot of bronchodilation. Okay. That went fast. I thought that was going to take some time. Say what?
No.